Hi, my name is Brady Banks, and I've created a MATLAB software to help calculate Mohr circles. The program is mainly geared towards Cal Poly students, specifically those taking CE 207, which is Mechanics and Materials 2. I created this program because I took this class last quarter, and I found that calculating the several values that go into these problems is very tedious. This program is meant for educational purposes only, to help students learn and to understand where they're going wrong with their problems. The program works by taking the user inputs here. On this whole section is user inputs, and then it will send it to several other functions that I've created, such as circle center, circle radius, input translate shear, input translate x, input translate y, and more. And then there's the main script, which is more practice one, just because I didn't rename it more final, but that's what it is. And then it'll send the modified data to these functions down here and down here. And that'll graph the Mohr circle and plot the points along with creating a table of values, which is all of this stuff down here. And that'll make it much easier to read the answers once they're calculated. Now, as you can see, this program looks very complicated, and it took several hundred lines of code to develop, not to mention all these functions over here. And as a result, not many people would understand everything going on behind the scenes, which would normally make the program very hard to operate. Fortunately, I added pop-up dialog boxes to make the data entry very easy and a step-by-step process. So I think the easiest way to showcase this is just to jump in and do some practice problems, kind of display my work to you. So I've got a Word document here. It's got some practice problems on it. And I'm going to go ahead and snap this to here and grab this. And then it says, for the state of plane stress shown, determine the maximum shearing stress when the stress in the x direction is 14 ksi, stress in the y direction is 4 ksi, and the shear is 12 ksi, as shown right here. So we're going to go ahead and we're going to run my program. And it's going to pop up immediately, ask for the x stress, which is 14 ksi, y stress is 4 ksi, shear stress is 12 ksi, and we're not translating from an angle, so we're going to type N for no, hit OK. It's going to ask us English units or metric, and we're using English, KSI. It's going to ask PSI, KSI, KSI, okay, and then it's going to give us a table of value and a Mohr circle. So as you can see, the table of value is kind of labeled the same as the Mohr circle. These blue dots right here are your x and y values. These are your inputs right here. And then it'll give you the center, the maximum shear stress, which is what we're looking for in this problem, and the principal stress, maximum and minimum. So then if we go down here, check the answer, we'll see that their maximum shear stress was 13 ksi, which is what we got right here. And there's a part B, but I'll save you the time and not display that one. Here's another problem. For the given state of stress, determine the normal and shearing stresses after the element has been rotated through 25 degrees clockwise, 10 degrees counterclockwise. So we're going to run again. The x stress is 0, the y stress is 8, and the shear stress is 5. And yes, we are translating from an angle. It's going to ask us what angle we want to translate, and clockwise is negative, so we're going to go negative 25, hit OK. English units, metric units, I believe we're in English units again, but let's go metric just to showcase it. It's going to ask pascals or kilopascals. I'll type K for kilopascals. And it's going to give us a table of values that looks a little different, and a Mohr circle that has another green line on it. So the green line is our rotated stresses. There are 25 degrees clockwise rotated stresses. And as you can see here, they're labeled, translated x stress, that. And we go ahead and go on down to the answers. We'll see that stress in the x direction is negative 2.4 ksi, negative 2.4 kPa because we chose metric. The shear is 0.15. We got 0.15 here, and 10.4 and 10.4 here. So as you can see, our program is a little bit more accurate than the homework assignment was, or this answer sheet, because we take it to more decimals. So we'll have a little bit more accurate answers, but if you round it off, it should be exactly the same as the answers given. So that is my Mohr circle calculator. I hope it helps you, and I hope you enjoy. Thanks.